So time, speed, distance. Okay, so one trick to solve problems which are based on time, speed, distance is first draw the line diagram, because that helps you in understanding the situation. Once you understand the situation, you can resolve it easily, right? But if you don't understand the situation, it would be really complicated thing to understand who is going where and what is the time, right? What is happening, whose speed is what, all these things. Okay,
Yes, sir.
so let me take you through. Okay, so speed is equal to distance by time. Speed is equal to distance by time. This is the formula, and this is the basic formula. And if you can understand this formula, you can solve any question which is based on speed, time, distance, because everything else is derived from this fundamental formula. Okay. Now, speed and distance are directly proportional if time is constant. So you come up with three situations, keeping one quantity out of these three: speed, distance, and time. Out of these three quantity, you keep one quantity constant at a time, right? So if time is kept constant, see this first case. If time is kept constant, then speed is directly proportional to distance, right? Now, if distance is kept constant, then what happens? Speed is inversely proportional to time. Okay.
Right, sir.
Now, third thing is, if speed is constant, then what will happen?
Distance is proportional to time.
Yes. Okay. So these are three fundamental relations which we draw from this particular relation. Speed is equal to distance by time. Now understand a few things about conversion from one unit to another unit. So 1 kilometer per hour. If you want to convert 1 kilometer per hour into meter per second, what you need to do? 1 kilometer means how many meters? 1000 meters, right? And 1 hour is equal to how many seconds? So 60 into 60. If you simplify that, what do you get? 5 by 18 meter per second. Okay. Similarly, otherwise also you can do 1 meter per second is equal to 18 by 5 kilometer per hour. Clear?
No, that's it.
So, and 1 mile per hour is equal to 1.6 kilometer per hour. Okay, so these are the conversion ratios, conversion formula you need to remember. Okay, because every now and then you won't be able to, derive it. So remember, 1 kilometer per hour is equal to 5 by 18 meter per second, right? And 1 meter per second is equal to, otherwise you just inverse it, 18 by 5 kilometer per hour. Okay, and 1 mile per hour is equal to 1.6 kilometer per hour. Okay, now average speed. Okay, so yes, we'll cover up basic concepts and then we'll get into questions. Fine, some more examples. Now, average speed. Average speed is equal to total distance traveled divided by total time taken. Understand? Total distance traveled divided by total time taken. Now, this is a question. Okay, we need to use this concept here. So, a person covers the first 150 kilometers of his journey at a speed of 30 kilometers per hour. The next 320 kilometers of his journey at a speed of 60 kilometers per hour. And the last 480 kilometers of his journey at a speed of 40 kilometers per hour. What is his average speed for the entire journey? Hmm. Can you try this, Rahul?
Yes, sir. We'll try.
Please. Tushar?
Trying, sir.
9.
No, sir, I'm trying. I said I'm
9.
trying.
Okay.
$43.19.
Okay. Rahul, what is your answer?
Sir, not arrived yet.
Not arrived. Right. Okay. So total distance is 950 kilometers. How do you get it? Question says a person covers first 150 kilometers of his journey at a speed of 30 kilometer per hour. So 150 and then 320 and then how much? 480. Total distance is 950. And total time is 22 hours. Right? So 150 divided by 30, you get here number of hours. And then in second case also 320 divided by 64. And then you get time and then 480 divided by 40. Right? You get that as well. So total time is 22 hours. And this is how 950 divided by 22, you get 43.18 kilometer per hour. Very simple, right? Cool. Now, when distance is constant, what happens when distance is constant? Then you got to calculate distance, right? So how to calculate distance? Distance is equal to speed into time, right? So for example, the question is a person covers 3 different stretches of same same length at a speed of 30 kilometer per hour, 60 kilometer per hour, and 90 kilometer per hour. What is his average speed for the entire journey? What will you do? So right, since distance is constant, it means all 3 distances are same. Fine, all 3 distances are same. So write d1, d2, d3, or d only. Fine. So on the top you will be writing total distance is equal to 3d, right? Divided by time taken. So time is how much? Time is equal to
60 kmph.
Distance by speed. Time is equal to distance by speed, right? Hello.
Correct, sir.
So write d by 30 plus d by divided by d by 30 plus d by 60 plus d by 90, and this is how you get it, right? This one. So d cancel from numerator and denominator, and this is what you are left with. So 3 divided by 1 by 30 plus 1 by 60 plus 1 by 90. Simplify, it goes 49. Okay. Now, next thing is time is constant. When time is constant, it means time in each case is same. So what happens? Total distance divided by total time taken. So a person covers a particular journey at 3 different speeds, 30, 60, and 90. So T1 is equal to T2 is equal to T3 because all three times are same. So 3 by 3T, right? It means basically it is nothing but simple average of all three speeds, right? So 30 plus 60 plus 90 divided by 3 will give you answer. Understood?
Okay.
Yes,
Tell me
sir.
if there is any difficulty because I'm a bit lazy, so I avoid writing, if it is not needed.
Got it, sir.
Okay. So this is how you get it. 30 plus 60 plus 90 divided by 3. Okay. This is actually pre-class work, and that's why I had shared that in the group, but you guys did not bother to go through. Now, relative speed. Understand what is relative speed? So speed of one body with respect to other body is relative speed. Relative speed is affair between two moving bodies. Understand? If there is only one object, then you will not talk about relative speed. Okay? So two bodies moving in same direction, then relative speed is equal to difference of speeds. If two bodies are moving in same direction, let's say speed of one body is 5 km per hour, speed of another body is 3 km per hour. Then what is the relative speed? 5 minus 3 is their relative speed because they are moving in same direction, right? Now, if they are moving in opposite direction, then it is always sum of speeds. If two bodies moving in opposite direction, then relative speed is equal to sum of speeds. Now, let's go through trains case. Okay, so you have three things.
So can you repeat the previous concept again?
Yeah, so if motion is in same direction, then relative speed is difference of speeds. If motion is in opposite direction, then relative speed is sum of speeds. Understood?
Okay.
So basically relative speed is nothing but it is the rate at which gap between two bodies is created or gap between two bodies is bridged. When two bodies are moving towards each other, what they are doing? They are bridging the gap. Understand? Life is all about bridging the gap and creating the gap. You make friends, what happens? You bridge the gap. You make enemies, what happens? You create the gap, isn't it? So let me take you through one example so that you understand it. This is A, okay, and this is B. Fine. Now, speed of A is, let's say, 10 meter per second. Speed of B is 15 meter per second. Okay. They are moving in same direction. Now, the question is, how much gap is created in 5 minutes? 5 seconds. How much gap is created in 5 seconds? So understand, first second what will happen? A will travel 10 meter, B will travel how much? 15 meter, right? So initially A and B were at same point. After 1 second, A travels 10 meters and B travels 15 meters. It means gap created between them is how much? 5 meter. So this gap is created in how much time? In 1 second. So that is why relative speed of A and B is 5 meter per second. Right? Relative speed is how much? 5 meter per second. So here gap is created. When motion is in same direction, gap is created between two bodies. Understood? So now I asked, after 5 seconds, what will be the gap created between them? So 5 into 5, that is 25 meters. Because in 1 second, they create how much gap? 5 meter. So in 5 seconds, 25 meter gap will be created. Understood? And you can simply count also. 15 5s are 75. Let's say this is 75. Okay, somewhere here, 75 meter distance. And this will go how much? 50.
50.
So what is the distance between them? 25. Same thing. Here you get, isn't it? Here you are using relative speed. Here you are not using relative speed. You are just calculating distance traveled by individual and then taking the difference. Understood? Now, let me take another case. So this is when motion is in same direction. Let's say there is C here. And C's speed is, let me take 15 only. Or let me take 12 here. 12 meter per second. Fine. Now, B is not moving. B is there. Okay. A is moving towards C, and C is moving towards A. What does it mean? It means they are moving in opposite direction.
Right, sir.
What happens after 1 second? A travels 10 meters. How much distance B travels? C travels? 12 meters.
12.
So initially, distance between them was, let's say, 100. Okay. How much was distance? 100 meter. What happens after 1 second? C travels 12 meters towards A and A travels 10 meters towards C. It means
70.
together they bridge how much gap? 22
meters.
meters. Right? So when motion is in opposite direction, gap is bridged. So 22 meter per second is the relative speed. Got it? Now let's say A is not traveling, B is traveling. What will happen then? After 1 second, B will travel how much? 15 meters, right? And A travels 12 meters. So what is the gap bridged? 27 meter. It means their relative speed is how much? 27 meter per second. Understood? So this
Right,
is the.
sir.
Is this clear now?
Yes, sir.
Okay. Now this is the situation. Relative speed and speed. 3 parameters are there in the matrix. Now stationary object. What is the situation? There is stationary object. It means it is not moving. Okay. Now let's say objects are train and object of negligible width. Two objects are there. One is moving, that is train, and stationary object is of negligible length. What is the relative speed in that case? Because one is not moving, so relative speed is speed of the train.
Same as the train.
Right? Now, see, this is electric pole. How much distance is traveled by this train to cross this electric pole?
Equal to the length of the train.
Yes, equal to the length of the train. Right? So now, if I need to find time taken to cross the pole, what will you do? Length of train divided by speed of train. Sorry, length of train divided by speed of train. Okay.
Right, sir.
Now, second case is train plus object of substantial width. Let's say one train is crossing another train, stationary train, or platform, anything. Fine. In this case also, what is relative speed? Relative speed is relative speed of train only. Okay. So this is how platform is. Now see, you need to figure out what is the distance traveled by a train to cover the or to cross the platform. Tushar, you there?
Sir, it is basically the length of train plus the length of this platform.
Yeah, simple, right? Cool. And relative speed is what? Length of train plus, sorry, distance. Length of train plus width of object. So that's platform and train. And what is relative speed? Relative speed here is only speed of train, right? So what is time taken? Distance by speed, right? You get it. Now, third case is moving object. So in moving object, what is happening? There is a train and there is object of negligible width. Let's say some person is moving or person is moving on a motorcycle. Okay. Now, both are moving. See. So what is the distance traveled by train? Length of train plus nothing. Because object does not have any width, right? So that is the total distance. What is total distance or relative distance? That's length of train only, right? What is relative speed? Since both are moving in the same direction, then relative speed is nothing but, Tushar,
Difference of two speeds.
sorry?
So the difference of two speeds.
Yes, difference of two speeds. Cool, good. Now, next case is one train is crossing another train or passing another train. Passing means motion is in same direction. Crossing means opposite direction. Okay. So this is how it is. Coromandel Express, Howrah Express. See, they're moving in same direction. Now, what is the total distance or relative distance? That is equal to length of train 1 plus length of train 2.
Train 2.
Right? And what is the relative speed?
Speed 1 minus speed 2.
Yes, because they are moving in same direction. If they move in opposite direction, then what will happen to distance? Relative
Adding,
distance?
adding the two speeds. Okay.
Relative distance will remain same, right?
Hmm.
But relative speed will be added.
Okay. Correct.
Cool. So you understood this case of relative speed, or is there any confusion in any case? Tell me, Rahul.
No, sir, clear.
Clear? Cool. Now, boats and stream. So boats and stream, this case is not a case of relative speed. Relative speed comes into picture when there is change in frame of reference. It means speed of one body with respect to other body. So basically you will find that there is no absolute speed in the universe, right? Every speed is relative speed. When I say that somebody is moving, some object is moving with speed of 10 meter per second on ground, what is happening? I am assuming that Earth is stationary because objects are moving on Earth. So with respect to Earth, since I am also on same platform, and that is why I am mentioning only speed of the person. Now let's say I am outside. I am there on moon or some other planet. What will happen? then relative speed will be,
More.
yes. Let's say you are standing outside the platform, okay, or on platform. There is a person in train. Let me tell you this scenario. Tushar, see, there is a train, okay, and there is a person who is standing here. Fine. Now you are standing, Tushar, here outside train. Fine. You are standing here. Train is moving with the speed of 50 meter per second. Person is standing here. What is relative speed of person? So when you see for the first time, what happens? You see him here, right? You will compare with how much distance traveled. And after 1 second, you see that this person has traveled till here, right? Somewhere. Here is the train. So this distance is how much? 50 meters.
It is basically the speed of the train only.
Yes. Fine. Now, same is the answer. What is the speed of the train with respect to you? Because you are stationary. Same, right? But if this person is moving in the direction of train with the speed 2 meter per second, what will happen? He started from here. This point of train is here. But 1 second he has moved how much?
2 meters.
So now person is here. So basically person has moved how much?
52 meters.
Yes, 52. Understood, na? 52?
Yes. Yes.
Rahul?
Sir, the same case would apply to any situation, say an elevator or an escalator as well.
We will come to that. So, Rahul?
Noted,
Understood?
sir.
Okay.
Yes.
Good. Now, so relative speed of this person with respect to Tushar, who is standing on platform, is 52 meter per second, right? Now, take another case. Let's say this person is moving in this direction with same speed, 2 meter per second. Then after 1 second, what will the situation? Instead of going forward, he would be here, right? 2 meter this side. So basically, how far from Tushar? Now, 48 meters. So then relative speed of this person with respect to Tushar is 48 meter per second. Clear? So whenever what is the cause of relative speed? Why relative speed comes into picture? Because there is change in frame of reference. Okay, if there is no change in frame of reference, there will be no relative speed. Okay, for example, 3 persons are moving, right? A, B, C, all 3 are moving. Speed is 10, 15 and 20. How do I say 10, 15, 20 meter per second? Because that is with respect to Earth. For all 3 persons, what is the frame of reference? Earth. Right? But if I say what is relative speed of A and B, both are moving in same direction. So relative speed of A and B is 5 meter per second. Relative speed of A and C is how much? 10 meter per second. Relative speed of B and C is 5 meter per second. Right? So, and if I say what is relative speed of A, B and C, there are 3 persons now. Right? Hmm.
Yes, sir.
Tell me.
Relative speed of C, na, sir?
No, relative speed of A, B, and C.
All moving in same direction.
No, I'm asking about relative speed.
Difference of 5, na? I mean, it will be different, na, for each. Like for A, it will be okay.
So see, relative word comes from word relation. Relation is defined between two persons only.
Yeah, that is.
Okay. So if I say relative speed, it means I'm just talking about speed of one with respect to other. It won't be among three. More than two people, more than two objects, relative speed does not exist. Okay. It's their individual speeds. Understood? Now,
Right.
coming to boat and stream. Let's say speed of boat in still water is A. So boat and stream is different case than relative speed, because here speed of one body is not influenced by, is influenced by other body. Fine. Here one body cannot be reference for the other body. So speed of boat in still water, let's say that is A. Speed of stream, that's current, is B. Then upstream. Upstream means opposite to current. Opposite to current. Opposite to stream. A minus B. Okay. Let's say river is flowing with the speed 10 meter per second. And boat speed is 2 meter per second in still water. Then what will happen? In the current, if no, what did I say? Speed of current is 10 meter per second, and speed of boat in still water is, let's say, 15 meter per second. Then case of upstream, what will happen? 15 minus 10, that is 5 meter per second. Okay. Now in downstream means in the direction of stream, what will happen? Speed of stream will be added to the steam speed of boat. So it becomes 25. A plus B. Got the difference? Now, speed of boat in still water. If you are given upstream speed and downstream speed, what can you do? If you add up, B will get cancelled and you are left with 2A. So divide that by 2. What do you get? You get A. And A is what? Speed of boat in still water. So that's why speed of boat in still water is equal to upstream speed plus downstream speed divided by 2. Okay. Similarly, speed of stream current will be how much? SD, downstream speed, minus upstream speed divided by 2. Same logic. Okay.
So can I note that earlier?
Yeah, I'll share the deck also, but if you want, you can note down. Mhm.
Done, sir.
Done. Hmm. Okay, now try this question. Raghu walks at 4 km per hour and reaches his school in 1 hour 45 minutes.
7
How far
kilometers.
is his school?
7 kilometers.
7 km. Okay.
So 7 kilometers.
See. Fine. Now, Ramu strolls at 4 km per hour to reach his school 1.4 km away. How long will he take?
$21.
Rahul?
Right, sir.
Hmm.
$80.
Hmm. Hmm. Next. Yes, please. Hmm. Hmm. See, a man goes for
So
a
1 minute,
jog.
sir.
Huh?
1 minute, sir.
How much?
So 6:15 plus 20, that is like
No.
6:40. And
See,
6:30, 6:35.
there are two things: jogging and walking, right? Now, ratio of speed is what? 4:3. Since walking is 25% lower than jogging, fine. Walking is 25. So if jogging is 100, walking is how much? 75. Is that clear? So what is the ratio?
Right, sir.
4:3. Now, ratio of time will be, because speed is equal to distance by
Distance.
time. So speed is inversely proportional to time. So ratio of speed will be inverse of ratio of time, or ratio of time will be inverse of ratio of speed. So ratio of speed is 4:3. Therefore, ratio of time becomes 3:4. Right? In jogging and walking. Now, this 3 corresponds to 15. How come? It is given in the question. He jogs for 15 minutes. So in this 3-minute time, he jogs for how much? 15 minutes. Is the ratio, right? This is actual value. What is the factor of multiplication? 5. So if you multiply this 4 by 5, what happens? You get 20. Because 3 and 4 are on same ratio scale. Jogging and walking are the ratios. Clear?
Got it, sir.
So total time is how much?
35 minutes. 6:35.
Good. So 6:35. Tushar, is this clear?
Yes, sir.
These are very basic questions for foundation. Okay, these are not GMAT questions. Now, Akbar, Babur, and Chandragupta set out for a certain place. Akbar reached in 20 minutes at 45 km per hour. If Babur and Chandragupta reached 5 and 10 minutes later than Akbar respectively, find their speeds. Would you try it?
So 36 and 30.
How much?
So 36 for Babur, Chandragupta is 30.
50. Okay. So see, Chandragupta, Babur, and time taken by Akbar is 20, Babur 25, and Chandragupta 30. Right? Is that fine? Now, time ratio. You just simplify, you get the ratio 4:5:6. Fine. Speed ratio 1 by 4, 1 by 5, and 1 by 6, because it is inversely proportional to time. Right? Multiply by 4, LCM of 4, 5, and 6, that is 60. You will get the ratio of time 15, 12, and 10. Is this fine till here, Rahul?
Yes, sir.
Okay. Now, First one, Akbar. Akbar, what is his speed? 45 kilometer per hour. So 15 corresponds to 45. What is the factor of multiplication? 3, right? So multiplication factor for Babar is also 3, and for Chandragupta is also 3. Then 12 into 3, 36, and 10 into 3, 30. So speeds are 36 and 30 respectively. Is that fine, or there is any confusion? Done?
Okay, sir.
Okay, go through this question. Hmm.
3.
Done? Rahul?
Sir,
Your
doing,
answer?
sir.
Okay, see. 4 kilometer in what time? 3 hours. 12 kilometer in 1 hour, right? And then 20 kilometer in how much time? 8 hours. Is that fine? Average speed you need to calculate. Just add up
3
total
kilometers.
distance and total time. 3 kilometer per hour.
Right.
Done?
Correct.
Yes, sir.
Good. Now, at 7:42 a.m., Lucky gets into a bus to go to school. What time? 7:42 a.m. The bus travels at 42 kilometer per hour and drops Lucky a short way away from the school at 7 o'clock 51 minute a.m. Fine. That's 9 minutes to 8 o'clock. He then walks the remaining distance at 6 kilometer per hour, thereby reaching school exactly at 8 a.m. What is his average speed for the journey? Can you do that?
So 23.33 kilometer per hour.
23.33. See. And then there's the situation. Right? Tell me what is happening. Bus starts at 7:42 and drops the guy at what? 7:51. It means for how much time it traveled? 9 minutes. And what is the distance traveled? So we can calculate the distance because speed is already given 42 km per hour. Right?
Correct.
So 42 into 9 by 60. Why I am dividing by 60? Because 9 is in minute. So to convert that into hours, I need to divide it by 60. Because the speed is given in this one, kilometer per hour. Okay. Then 51 to 8 o'clock. Again, how much time? 9 minutes. Guy traveled with the speed of 6 km per hour. So again, 9 by 60 into 6. How much? 0.9 kilometers. What is the average speed? Sum of distance divided by time taken. So distance is how much? 6.3 in first case and 0.9 second case. Right? That's how much? 7.2. And what is the time taken? Time is already given 9 minutes, 9 minutes, 18, right? Convert that into hours. So it becomes 18 by 60. So 60 goes on denominator. And therefore you get this 7.2 into 60 divided by 18, which is equal to 24. You got it? Any confusion, guys? Anywhere?
No, sir.
Additionally, since the time taken in both the cases same, average speed is directly proportional to average of two speeds. That is twice of S1, S2 divided by S1 plus S2. What is that? When distance is constant, then average speed is given by twice of S1, S2 divided by S1 plus S2. Where S1 and S2, the speeds. Clear? So this is how you can get it. Time is same, then average speed is nothing but average of speeds. So divided by this one. Okay. Now, when distance is not given, speed and time are given, then we calculate average speed like this: S1 T1 plus S2 T2 plus S3 plus T3 and so on, divided by T1 plus T2 plus T3 and so on. Okay, this we have already discussed. Now, try to solve this question. Hmm.
Is it 20?
20. Okay, see what happens. Total distance is how much? 0.8 kilometer, 400, 400. right?
Right, sir.
Then time for first 400 is equal to how much? 0.4 kilometer. That's 400 meters divided by 18. Now time for second is how much? Divided by 22, right? So you get this. Now average speed is equal to 0.8 divided by time taken in each case. Clear? Otherwise, what you can do? You can directly do twice of S1 S2 divided by S1 plus S2. That is twice of 18 into 22 divided by 18 plus 22. This will also give you same thing. Okay. So going forward, use shortcut. Done. So this is the final answer, 19.8 kilometer per hour. Clear? Alternatively, yes, same formula. 2ab divided by a plus b. And you get same answer. Done? Tushar, are you with me?
Yes, sir, done.
No. Ravi usually takes 1.4 hours to reach school. If he walks at 75% of his usual speed, how much time will he take? Hmm.
1.86 hours.
Hmm.
Yes, sir, 1.86.
1.8, yes. Again, ratio of speed is 4 is to 3 because his speed is 75% of usual speed. So if usual is 4, new speed becomes 3, right? Ratio of time is 3 is to 4. Actual time, how much is given? 1.4 hours usual, right? So that is 1.4 hour means 84. Hence 1.86. Fine. Hmm. Hmm.
40 minutes.
40 minutes.
Yes, sir.
Hmm.
So we can do this in a different way also. Like 5 by 4, like 1/4 is 10 minutes, so 4 by 4 is Actually, it is from 50, is it? Yes. No, sorry.
Tushar,
Yes, sir, getting it.
got it? Okay. So difference of time is 1 unit. Since 1 unit is equal to 10, therefore 5 unit is equal to 50. Just a ratio proportion concept. Huh. Hmm. Yes, please.
So 1.5 hours, which would basically mean 11:30 a.m.
Hmm. Okay. See what happens. 15 kilometers the distance, right? This is how they are meeting. Moving in opposite direction, the relative speed is 4 plus 6, 10 kilometer per hour. Also, they cover 15-kilometer distance. It means it is simply 15 by 10 kilometer per hour. How much is that? 1.5 hours or 1 hour 30 minutes. Cool. So 11:30.
Right.
In the previous question, after Akbar and Birbal meet, they chat for half an hour and then leave for their respective homes. At what time will they reach home? Hmm.
12:30.
Hmm? How much?
12:30. No, sorry. 12:30. 1:30. 1:30 p.m.
11:30. They meet. They start 12, and will be there at their places. So after 30-minute chat, his time would be how much? 1:30.
1:30 p.m.
Okay, cool. Huh. Daisy and Donald start moving towards each other from their home, 24 kilometers apart, at noon. Okay. Daisy walks at constant speed of 5 kilometers per hour, while Donald walks at constant speed of 7 kilometers per hour. How far away from each other will they be 10 minutes before they meet? This question is a bit tricky. Done? First calculate time taken by them to meet, and then subtract 10 minutes from that. See how much distance is covered by each them in that time. Simple. Hmm? Five.
So is it 3.5 kilometers?
Okay, let me tell you. 2 kilometers apart from each other, 10 minutes before they meet. Hmm? If they are at same point, how much time will they take to create the uh, gap between them? This way.
Sir, I did it like this. Basically, they'll meet in 2 hours. So
Okay.
I calculated the distance that each of the two covered in 1 hour 50 minutes.
Hmm.
And then I took the difference. For me, it's coming 22 by 6. I think this might be a calculation mistake, but it's the approach, right?
See, first you calculated
Uh, so they'll meet in 2 hours.
when they meet, right? So they meet in
Yes,
how much time?
2 hours.
They meet in 2 hours. Okay.
Yes.
Now the question is saying Daisy walks at constant speed 5 and constant speed. How far away from each other will they be 10 minutes before they meet?
Hmm.
Right. So now in this case, what you can do is in this approach, you can calculate how much time they take to meet, right? 2
Hmm.
hours.
Yes.
Now, so before 10 minutes,
Hmm.
how much distance they will cover? And then,
Oh,
and then look at the distance. So basically, you subtract that from 24. So
got it.
this is what you can do. Otherwise, understand this logic.
Got it.
Two objects take t time to cover total distance d when moving towards each other. And they will also take t time to cover total distance d when traveling away from each other. Right? See what is happening. These two balls are there. Time taken by them to meet and time taken by them to go back to their original position is same
Hmm.
now. So let's say they are at same point. In 10 seconds, 10 minutes, what happens? There is somewhere this way. Okay, there. So 10 minutes before, calculation would be 10 by 60. Convert that into this one, and that is what their relative speed 5 plus 7.
Got it.
They are moving opposite. Okay, basically how much distance is, how much gap is created between them. Now, Ricky snatches Vicky's wallet and starts running away at a speed of 6 meters per second. After 5 seconds, Vicky starts chasing Ricky at 8 meters per second. After how much more time will Ricky be caught? What is happening here? Both are moving in same direction. So you can do this thing that in 5 seconds, how much distance is traveled by Ricky? And then that distance
So I will take up
becomes relative.
now.
That distance becomes relative distance. Relative distance divided by relative speed. Good. This way. Hmm? Clear? Done, na?
One second.
Hmm.
So I will. Is it okay if I can skip now? I will attend it in the this.
So you solve this sheet, this document. Okay. This deck is shared in the group. Go through that. This is
Okay.
pre-class work, which I'm doing now, because you guys
Okay.
don't do before class, no?
Okay, sir. I will do it.
Okay.
Sir, I also take this, like, complete this and
Fine.
before
So
this.
just finish this question and then.
Okay.
Okay, Rahul?
Yes, sir.
Hmm. And next class we will be discussing GMAT questions. No, these are for your
Okay.
basic understanding of the topic. Yes, please. See solution. Okay, what is happening? This how they are. Mike is showing off his new car. He drives along the road at a speed of 20 meter per second, overtaking a truck 12-meter long, which is moving in the same direction with a speed of 15 meter per second. If he takes 3 seconds to overtake the truck, it means he will have to cover a traveled length of truck plus its own car, right? His own car. What is the length of his car? This is what. Okay. So how it goes? If length of car is x meter, time taken to overtake the truck is how much? 12 plus x divided by 20 minus 15. That is relative speed. Okay. It is equal to 3 seconds. It is given. You just simplify this and you get the value of x. X equal to 3 meter. Since car length of car is 3 meters. Is that done? Guys?
Right, sir.
Yes, sir.
Okay. So this has how many slides we have covered? I want you to cover all the remaining slides also. Okay. Please do that. 29. We have done 29 slides. Fine. And 46 are there total. Clear?
Yes, sir.
Ah.
Sir.
So do that. This is shared in the group. Okay. Bye bye.
Thank you, sir. Have a nice Sunday. Thank you.
Thank you. Bye-bye.